is given as dm over dt equals to km, where k is constant. Okay, find the general solution for m in terms of t, where the initial amount of food is mo grams. Okay, to do that, okay, you need to split m on one side, dt on the other. So keep m on the left, then dt on the right, and this should be morning. Okay, now rearrange this. Dm over m equals to k dt. So integrate on both ends, you get k dt. Okay, so integrating m will give me ln m. Ln m equals to kt plus c. So m equals to e to the power of kt plus c. So m equals to e to the power of kt times by e to the power of c. Since c is constant, then e to the power of c is also constant. Doesn't matter what is c is. C could be any value, but the moment c is constant, e to the power of c is also constant. So I can change e to the power of c into another letter. So m equals to e to the power of kt multiplied by a. So your equation here is m equals to a times by e kt. Okay, since the m equals to mo, the initial amount of food is mo gram, therefore by substituting m with mo, a multiplied by e to the power of kt, when t equals to 0, you get mo equals to a times by e to the power of 0. So from the mo equals to a to the power of a times by e to the power of 0. So mo equals to a. So from there, the differential equation is m equals to mo times e to the power of kt. Okay, question B. Find the value of k if after 30 days only half the initial amount of plant food is effective. So k, to find k, t equals to 30 days. So sub t with 30, m equals to mo multiplied by e k times by 30. So m equals to mo multiplied by e to the power of 30k. So m o over 2 equals to m. So when we sub that, mo over 2 equals to e to the power of 30k. So e to the power of 30k equals to half. So using ln 0.5 equals to 30k. So k equals to 0.0231 0.05. So if I deduce a formula, m equals to mo e to the power of negative 0.023105. Okay, m is the amount of grams of plant food present. Okay, plant food. Whereas mo is the amount of plant food present after so many days. When t equals to 35, okay, we have m equals to mo e to the power of negative 0.023105 t. Okay, we know mo is the amount of food that present after so many days. So if m equals to 35, okay, what is the amount of food present after 35 days? So this can be done by taking m divided by mo and e to the power of negative 0.023105, and this time t is 35. So to find out what is the percentage amount of food that's present after 35 days, so you sub 35 and m over mo equals to 0.44544. So from here we know it is about 44.5%, approximately 45%. Okay, so m is grams of plant food that's effective, whereas mo grams of plant food that is present and effective after t days. So question D. The plant food to be renewed when its effectiveness fall below 25% if the manufacturer plant justified in calling the product 60-day superfood. Okay, so in this question we have to find 60-day superfood, meaning after 60 days does the amount of food is 25% of the original. After 60 days the amount left is 25% of the original amount. So again, m over mo equals to e to the power of negative 0.023105 t. So after 25 days, m over mo, it'll be e to the power of negative 0.023105 times by 60. Okay, so if I do this, there are two methods for us to do. Okay, to find out whether we have 25% left after 60 days or m over mo equals to 25%, and from there we should get t as 60. Okay, let's do both methods. Okay, e to the power of negative 0.023105 times by 60. The answer that I got is 0.2 2499, which is approximately 25% left. Okay, or you can take 0.25 equals to e to the power of negative 0.023105 t. So negative 0.0231105 t equals to ln 0.25. So from here we know t equals to t equals to 59.999, approximately 60 days. So it is justified to call 60-day superfood.